We have seen how to find absolute extrema of a function, and now we're going to utilize this in a concept that's very popular in calculus called optimization. So optimization can be a little bit tricky at first because you're going to be dealing with a lot of word problems. You're optimizing real life situations. So I'm going to do three examples here. The first one, I'm just going to begin by it's a small problem, but it helps us kind of set up and see what optimization do. Keep in mind that when you're optimizing, you are either going to be finding a minimum or a maximum, which means that you are for sure going to be using the first derivative. So we have a question here. Find two numbers whose difference is 19 and whose number is a minimum. So a lot of times when you're working with word problems, you need to assign variables if it hasn't been assigned, and it hasn't here. So I'm looking for two numbers, so I need two variables. So I'm going to call them x and y, but you could call them like smiley face and angry face. It doesn't matter, right? So I'm going to let x represent the first number and y represent the second number. I know their difference is 19, so the difference is a subtraction. So x minus y is equal to 19. And I know I want their product to be a minimum. So this is the key. One of the very, very important thing in optimizing is figuring out what you're trying to minimize or maximize, because that's going to be the function you take the derivative of. So I want to make the product a minimum, so I'm going to have to take the derivative of the product. So P is equal to, product means multiplication. Now, in optimization, you're going to have two types of problems. The first one is that your function that you're optimizing has one variable. If that's the case, then you can immediately go to the derivative. You can take the derivative like you're used to taking the derivative. The second one is that what you're trying to take the derivative of has two variables. And when that happens is that it will give you another equation to make it one variable. So in our case, that's the x minus y equals 19. So what you do here is that you solve for one of them. I'll solve for x. That will give me 19 plus y. And then you plug it into the product. And that will make it a function of only y. So it'll be 19 plus y times y. So now I need to take the derivative of this because I'm trying to minimize it. So first, before I take the derivative, I'm going to distribute the y. And then I'm going to take the derivative. So that will give me 19 plus 2y. And then we go to finding the minimum. So first we have to find the critical number. So when is it 0? And when is it undefined? So 19 plus 2y is equal to 0. 2y is equal to 19. Y is equal to positive 9.5. Oh, right here, I made a little mistake. This is going to be a negative 19, negative 9.5. It's never undefined because it's a line. So I only have one critical number. I need to see if it is a minimum or a max. And now you have a choice. You can either do it using the first derivative test or the second derivative test. I'm going to use the second derivative because it's so easy to find the second derivative of this function. The second derivative is 2. So when I plug in negative 9.5, it's still going to be 2 because it's a constant. So greater than 0 means a min. So check. Do not assume whether it's a min or a max. It's a very common thing that I see people miss. So now I have the y, but I'm missing my second number. So I need to plug it into where I solve for x. So I get x is equal to 19 minus 9.5. So x is equal to a positive 9.5. So my two numbers are 9.5 and negative 9.5. Perfect. Okay, let's take a look at another one. A company manufactures and sells X headphones per week. The weekly price, demand, and cost equations are. So it gives us the equations now. And it's only in terms of X. What price should the company charge for the cameras? And how many cameras should be produced to maximize the weekly revenue? What is the maximum revenue? So they're actually asking us for three things here in one question. They're asking us for the price, how many cameras, and the revenue. But what is not changing in all of those is that we're maximizing revenue. So we are going to have to take the derivative of the revenue function. Now, if I take a look, I have not given the revenue function. I am given the price and the cost, but I can find the revenue because revenue is price times how many you're selling. So my revenue function is going to be 400 minus 0.5x times x. So just like I did before, first I'm going to distribute the x. And then I'm going to take the derivative. So that's going to give me 400 minus 0.5 times 2 is 1, so minus x. So when it's a 0, so 400 minus x is equal to 0, that gives us x is equal to 400. It's never undefined because it's a line. So I need to check whether this is a max. I'm again going to take the second derivative. So r double prime of x is a negative 1. So when I plug in 400, it's still a negative 1. And less than 0 means that it is a max. So check. So I have the amount of cameras. I know that it's 400 cameras that's going to maximize revenue. So that's one part of the question. It's asking me the price they should charge. So I need to plug in 400 into the price function. So that's going to be 400 minus 0.5 is 1 half. So 1 half times 400 is 200. So it's going to be $200. That's my price. I'm going to write it here. And then they're asking me what is the maximum revenue. So I need to plug in 400 into the revenue. So that's this function right here. And when you plug in 400 into the revenue, you can compute that. It will give you 80,000. Okay, so here is part A. So part A is done. I'm going to do it in orange. I'm maximizing revenue at 400 cameras. The price is 200. The revenue is 80,000. Now I can go to part B. It's asking me what is the maximum weekly profit. So I'm changing now what they're asking me for profit now. So I need to find the derivative of the profit function. So it doesn't give me profit, but I know that profit is revenue minus cost. So that's going to give me my revenue function, 400x minus 0.5x squared, minus my cost function. And remember, we talked about this a lot when we were doing marginal analysis. Put that in parentheses. So that's going to give me 400x minus 0.5x squared minus 2000 minus 200x. I can combine like terms. The first and the last are like, so it gives me a positive 200x minus 0.5x squared minus 2000. Now I will take the derivative, p prime of x. I get 200 minus x. I set it equal to 0. I get x is equal to 200. It's never undefined. I need to make sure it's a max, so I'm going to use again the second derivative test. It's a negative 1. So when I plug in 200, it's still negative 1. Less than 0 means it's a max. But it's not asking me how many cameras gives me a max profit. It's asking me what is the max profit. So now I need to plug in 200 into the profit function, which is this little guy right here. This is where I finish my profit function. And so when I do this, it's going to give me 18,000. And you can double check that in your calculator work. So here's my answer for part B. Part B, they only asked me one thing. They asked me, what is the profit? But what I really, really want you to be careful of here is what function I'm taking the derivative of based on the wording of the question. So in part A, they were asking me for the max revenue. So I had to take the derivative of the revenue function. And in part B, they were asking me for max profit. So I had to take the derivative of the profit function, right? So it's the key, right? So you have to really read what they're trying to ask you to optimize. Let's do one more. A cafe sells 750 wraps per day at a price of $7 each. A market survey shows that for every 20 cents reduction in price, 30 more sandwiches will be sold. Okay. How much should the deli charge for a sandwich in order to maximize revenue? All right, so the key here is, again, that we're trying to maximize revenue. So we need to take the derivative of the revenue function. Now, it doesn't give us the revenue function, so we need to figure that out on our own. So what do we have? We know that a cafe sells 750 wraps a day, and they sell them at $7. And then it tells us that if we reduce it by 20 cents, there will be 30 more sandwiches or wraps. So currently, what I'm going to do is I'm going to do my current revenue. My current revenue, which remember, current revenue means price times how many you're selling. So that's 750 and 7. So my current revenue is 750 times 7. Now we need to look at what happens when we change things. So the first thing we could change number 1, would be that first, I reduce the 7 by 20 cents one time. And if I reduce it by 120 cents, I will add 30 sandwiches. So reduction means minus, increasing means plus. Or I could reduce it twice. So it's 20 cents. Oh, too many zeros there. So I reduce it 2 times by 20 cents, so by 40 cents. And if I reduce it twice, I will add 30 2 times. So plus 30, plus 30. And I can keep doing this, right? So I can add 30 3 times and reduce it by 20 cents 3 times. So every time I do a 20 cents reduction, I add a 30. So what is changing is the amount that you're subtracting by 20 cents and the amount that you're doing by 30. So in this one, it's 1 time. In this one, it's 2 times. In this one, it's 3 times. So I can make a function where x represents the amount of times. So I can do r of x is equal to 750 plus 30x times 7 minus 20 cents x. So if I do it 1 time, it's 20 cents 1 time, 30 1 time. If I do it 2 times, it's 2 times 20 cents, 2 times 30, and so on. And now I created my revenue function. So the best thing here to do is, again, you can use the product rule to take the derivative, but I would say probably the better thing to do would be to first FOIL out, because that would be a little bit easier. So you have 750 times 7, which is 5,250, plus 210x minus 150x minus 6x squared. Combine like terms, 5,250 plus, combine these right here, 60x minus 6x squared. Now we're going to take the derivative, r prime of x. That's going to give us 60 minus 12x. When is it 0? 60 minus 12x is equal to 0. I get negative 12x is equal to negative 60, which gives me that x is equal to 5. It's never undefined. Because x is equal to 5 is part of the domain, it's a critical number. So I'm going to use the second derivative test. So r double prime of x is a negative 12. If I plug in 5, it's still negative 12. Less than 0 means a max. Check. Now, I need to go up to see what they're asking me. They're asking me, how much should the deli charge for a sandwich? So if I go back to my revenue function, which is right here, this is my revenue function. The first part represents how many sandwiches you have, and the second part represents the price that you're selling them at. And it's asking me, how much should the deli charge? So I need to come over here with the pink. The pink is what I want, and I need to plug in my x. So 7 minus 20 cents times 5. So that's 7 minus $1. So I'm going to charge $6, right? So a very common thing that I see is that people just answer x equals 5, but most of the time it's not the x that you want. They're going to ask you something specific in the question. In this case, it was the price. So you are going to do 5 20 cents reduction from $7, which will make it $6.